Now let's relate uh, mass, mole, and Avogadro's numbers. So let's relate them together now. So remember we said 1 mole of a substance contains 6.02 times 10 to the power of 23 particles of that substance. So if you say, for example, we want to, if the substance now, if our substance is carbon, so we can say 1 mole of carbon, which weigh 12 grams, which is the mass of 1 mole, remember? So again, when we say 1 mole of carbon, so let me put the name of this substance, 1 mole of carbon. What is the mass of 1 mole of carbon? We established up there that mass of 1 mole of carbon is 12 grams. So which equals 12 grams of carbon. And how many particles are we going to have in 12 grams of carbon? We are going to have 6.02 times 10 to the power of 23 particles of carbon. So in that 1 mole of carbon. So you can use this now for any calculation. For example, if they hide the mass of carbon for you and you know the mole, you can determine the mole and the Avogadro's number, then you can determine the mass of carbon. Or you are given the mass of carbon, you are given the Avogadro's number, you can determine the mole of carbon. When I say mass, I mean the mass of 1 mole of carbon. We're going to do that in our calculation very soon. So before we go ahead with calculation in this part, there is one other relationship that we want to consider, the molar mass and mole. So if you want to use an equation to relate molar mass of a substance to the number of mole of that substance, of course you know that. We know that number of mole, you know that from your secondary school, equals mass of the substance over the molar mass of that substance. Now remember they said molar mass. Molar mass, it means mass of 1 mole of that substance. There's a triangle that we normally use to relate this. We call it mole triangle. I hope you can remember this. So where we have the mass on top, and then we have the mole on this side, and then we have the molar mass at this side. Now, what relates mass to mole is division. So I will just cut this part. This is so big. So what relates mass to mole is division. So we can just put division here. So I draw the line and I put division here. What relates mole to mass is also division. So I put a division line here. And what relates mass and molar mass together is multiplication. So what do we mean by that? From the equation up here, if you want to determine the mass of a substance, what you just need to look is that, okay, mass of a substance will equal to mole times molar mass of that substance. Again, let's look at that together. You want to determine the mass of a substance. So if you just cover the mass of that substance like this, what do we have left? We have mole times molar mass. So it means you can just say mass equals mole times molar mass. So we use MR, which is relative molecular mass, to represent molar mass. It's the same thing. The only difference is that MR will not have unit. Anyway, let's go. Now, if you cover, let's say we cover mole, we cover moles. So what do we have left? We have mass divided by molar mass. Look at the division line here. So we have mass divided by molar mass. So it means mole equals mass divided by molar mass. If you cover, let's assume that we cover before that. Let me remove this. So let's assume that we cover MR. What do we have left? We have mass divided by mole. So it means molar mass, which is MR, equals mass of a substance divided by the mole of that substance. So let's put our MR back. So, and then we remove this part. So that is how we relate three of them. So just make any one of them the subject of the formula. If you want to calculate mole, mole equals mass over molar mass. If you're calculating mass is going to be mole times molar mass. If you're calculating molar mass is going to be mass divided by number of mole. Okay, so based on this, we can start our simple calculations regarding moles, mass, Avogadro's number, molar mass. So let's look at this first example. So when you have a question where they're asking for number of atoms, if you look here, the question says calculate how many copper atoms. How many copper atoms? So asking for copper atoms here means they want you to use Avogadro's number. So they want you to use the Avogadro's number when they ask for number of atoms, or they ask for number of ions, or they ask for number of molecules. So remember, we said 1 mole of a substance, 1 mole of a substance equals, that is, it contains 6.02 times 10 to 23 atoms of that substance, and our substance here is copper. So, and then we know that 1 mole of copper equals equals 63.5 grams of copper. Remember, that is the molar mass of copper. That is, mass of 1 mole of copper is 63.5 grams. And then we know that 1 mole we have this number of particles. So we can just equate it here as well. We'll say it equals to 6.02 times 10 to the power of 23 atoms of copper. So what this one means is that when you have 1 mole of copper and you weigh it, it will weigh 63.5 grams. If you count the number of copper atoms in that 1 mole, it's going to be 6.02 times 10 to the power of 23. So this is going to be the basis that we are going to use for our calculation. So in the calculation, what do they give us and what are we looking for? So they give us the mass. So it means we need this part. And then we are looking for the number of atoms. So we need this part, like this. That is the part we need for our calculation. So let's go ahead and use that part for the calculation. So So this part, let me rewrite it here quickly. 63.5 grams of copper contains, or we can just say equals to 6.02 times 10 to the power of 23 copper atoms. So this is our basis. And then we'll now put our question under the basis. So we were given 3 grams of copper. So this is grams, so we'll put 3 grams under the grams here. We're looking for number of atoms. So this is going to be question mark. So if you like, you can change this question mark to X the way we used to do. The way you used to do in secondary school, so we just put X here. And then the next, we have to equality sign, we need to cross multiply. So it means X multiplied by 63.5 grams equals 3 grams multiplied by 6.02 times 10 to the power of 23 atoms. So we are looking for X. We make X the subject of the formula. That is easy from here. So we're going to have X 3 grams times 6.02 times 10 to the power of 23 atoms divided by 63.5 grams of copper. So grams will cancel grams. So if you press your calculator, you are going to get 3 times 10 to the power of 22 atoms. So you're going to have 3 times 10 to the power of 22 atoms of copper.